Hi, welcome to Computing Foundations. This is a channel for beginners who want to learn about computers, programming, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. We're continuing our process of learning the C programming language, and today's topic is arrays. Arrays are a type of variable that are used to help programmers be more efficient in writing certain kinds of programs. So let's dive right in and learn a little bit about the reasoning behind arrays. Why do we need arrays? So to get your head around this, I want to start with an example, and that is the example of American baseball. In American baseball, the way that we organize the score of the game is that we have two teams and we have 9 periods in the game, or what are called in baseball innings. And in each inning, each team has a chance to bat and hit the ball in an attempt to score points. It's not that important that you understand the details of baseball, but just understand that it's a game with 2 teams and 9 periods of play, and each team can have a score in each period of play. So I want to ask, with the information that you have today, how would you go about writing a program that would keep track of 9 different scores for 2 teams, so a total of 18 scores, and print those scores out to the screen? Now, to demonstrate to you kind of how messy this could be if we only had the tools that we've learned up until now, I've prepared a program for you that I have called Bad Baseball. This is program number 10 to go with this particular video. So if you open that up or just look at my screen here, what I'm sharing with you, I want to walk you through the process of the program and kind of demonstrate to you how challenging it could be to write. Let's start with the main function. So first of all, I have 2 teams. I need to define variables to hold 9 scores for each team. So the only tool that we have right now is to define 9 integers, and I have to give each one of them a unique name and set them to 0. You may not have seen this syntax before where I can define multiple variables in the same statement by simply separating each variable name with a comma. This is just a shortcut. I could have put each of these int declarations on a separate line and we would have had 9 lines defining 9 integers. Look, I have to do the same thing for team 2. I have to come up with unique variable names for each. I'm using the format T1, which is team 1, and T2 for team 2, and then I1 and I1 for inning 1, I2 for inning 2. You get the idea. So this line here on line 27, I'll explain it to you in just a moment. It's not something we've learned a lot about, but this is initializing a random number generator. And that isn't really important for the purpose of this program. I'm just going to use it to help us write the program in a little bit simpler of a fashion. So the first thing I'm going to do is print out the initial scoreboard. And in order to print the scoreboard, I've created a function, something we've learned about. This function, which is called print team, we'll look at the definition in a minute. It receives the number of the team. Is this team 1 or is this team 2? And then each of the 9 variables that represent the current score for that team right now. So let's look at print team and see how it works. Starting at line 12, I define a void function that doesn't return any values. I give it the name print team, and here I define basically 10 integers. The first integer is the number of the team, and the rest of the integers are the scores. And then I have this printf statement that will print out kind of a pretty little representation. It looks like what you see down here at the bottom of my screen. It'll print out kind of a pretty representation of the scoreboard with whatever team and then a line for the scores of the team in each inning. And you see here I have to reference each of the 9 variables. I have to create 9 different format strings here to indicate I'm going to print out 9 integers. And that's how the print team function works and helps me not to have to rewrite these 3 lines of code over and over again in the program. So let's continue. We print out the scoreboard for both teams. Now, I want to go through each inning of the game. I'm pretending like the game is proceeding. And in each inning of the game, I'm going to assign a score to each team. I've created a function called getRandScore, get a random score. And this function is the reason that I had to initialize the random generator on line 27. You don't really need to understand how a random generator works. Just understand that I've initialized the random number generator so that when I call getRandScore, the generator is ready to create a random score. Then in getRandScore, I simply return a random number moduloed by 11, which means I will end up with a number between 0 and 10. There's 11 different possibilities that I've created. So I'm going to get a random score between 0 and 10, and I'm going to assign that to an inning for a team. So coming down again, I print out scoreboard inning number, let's start here, inning number 1. I have a format string to replace the %i with a 1. Inning number 1. I set a random score for each team. I call print team for both teams to print out the current scoreboard. Okay, then I have to do it again. Inning number 2. I get a random score for each team. I print out the scoreboard for each team. Inning number 3, inning number 4, all the way down to inning number 9. So I've ended up with a program that's almost 100 lines of code, and it is going to get a random score for each of the 9 innings for each team, print the scoreboard onto the screen. I'll just make my terminal a little bigger here and show you an example. After each inning, we will print out to the screen the current score of each team. Let me run this for you one more time because I am not showing you this actual program. Hold on one second. Okay, I've just recompiled this program and I'm gonna run it again. All right. And again, let's just look at the output. So starting at the beginning of the program, I write the initial scoreboard. Everybody's got a 0. Inning 1, a random score has been assigned for both teams. Team 1 got 2 points. Team 2 got 8 points. Inning 2, I update the next variable for the second inning. Team 2 got 2 points. Team 1 got 2 points. Team 2 got 8 points. Next round, Team 1 got 0 points. Team 2 got 7 points. So you're beginning to get the idea of how the program functions. All right, this is a really difficult program to write. It's very messy. I have to rewrite the same code over and over again. So this is where arrays come in. And let me jump back to my paper and start to discuss what is an array and how would it help us with this program. All right. An array is a special kind of variable. And here I'm showing you I define an integer called age. That's what a normal variable definition looks like. This is what a array variable definition looks like. I have a type, a name, and then in brackets, a number. So what is this statement saying? So let's first start with the first variable, age. When I say int age, as we've discussed in the past, the computer will reserve 4 bytes of memory. So each of my lines here represents 4 bytes. It will reserve 4 bytes of memory. It will store 44. And now from henceforth, I can use age as a name, a variable name, to refer to this area of memory. Now, when I define an array like this, int array 9, what the computer is going to do is assign a block of memory that represents 9 integers. So that's a total of 36 bytes of data that get reserved in memory continuously, one continuous block of memory, and the compiler associates with this entire block the name innings. Okay? And when I want to set a value or read the data in one of these different integers, all I have to do is write down the name of the array and then in brackets an index for which one of these integers do I want to address. Now, how do indexes work? Okay, if you have defined an array of a given type and you've given it a size n, the indexes of the array go from 0 to n minus 1. So we say that arrays in the C language are indexed based on 0. So what does that mean? It means to get this first integer of memory, I just need to say innings bracket 0. To get the second position, I need to say innings bracket 1. That tells the compiler, hey, I want to go into the memory block called innings, and I want to access the second memory location, all the way up until we get to the maximum value for the array, and I can address that as innings 9. And I can't go any higher than 9. I just made a mistake. Innings 8 is the maximum number I can put there because I only have 9 spaces, and the first space is indexed 0. So the 9th space is indexed 8. If I had put a 9 here, I'm referring to something that doesn't exist. It's a piece of memory that doesn't belong to me. So we don't want to do that. We'll talk more about that in a minute. All right, so this is basically how an array functions in memory. So let's look at how do we initialize arrays. I can initialize an array at the moment when I declare it, just like I can with other integers. But because I need to reference multiple values, one for each element of the array, the way that I do it is I open up a curly bracket and I use a comma-separated list of literal constants, and this will fill my array with 4 numbers. Now, let's imagine I wanted to update the age of my oldest child because he had just had a birthday. How would I do that? Well, I want to go to the 4th position in the array. That means I'm going to use the index 3 because this is position 0, 1, 2, 3. So I come to the 3rd position in the array, and I just treat it like any other variable. I can do a plus equals 1 to increase it by 1. And now the data stored in the 4th element of the array, which has the index 3, will have the value 10. So this is how we initialize and change the values of an array. Now let's discuss a little bit about out of bounds, which is the mistake I just accidentally made up here when I wrote a 9. Each array has a size that we've defined, And if I try to access an element beyond its size, so here for the children's array, 4 is referring to the 5th element of the array, which doesn't exist. This is a programming bug or a programming error. Sometimes your compiler may catch this and warn you about it. Sometimes not. The compiler may happily program the program and the program may run just fine. But what's happening is you're writing a value into an element of memory that doesn't belong to you. It's as though the compiler reserved 4 locations for you in memory, and you can access each of them with index 0, 1, 2, and 3. But if you try to access index 4, you're accessing an area of memory that may have already been reserved by the compiler or the computer for some other use. That may be some other variable, and now you're stepping on it, you're trampling on it. This may cause your computer to freeze and you'll have to reboot it. It could just cause your program to have weird results and weird errors. It's not exactly something the compiler is going to stop you from doing, but it's probably not what you intended to do. You didn't want to try to write data in an element beyond the boundary of the array. This is a very common error in C programming language. Lots of modern languages protect you more against this. They make compiler errors or runtime exceptions if you run past the bounds of an array, so that if you make this mistake, at least your program will stop and it won't do any damage, and you'll get a warning that explains to you why your program has failed. Our C program may just go ahead and run and do exactly what we're asking it to do. We're asking it to write a value into memory that it doesn't potentially own or that isn't really related to this variable array. All right, so be careful with out of bounds. All right, let me give you now your second programming challenge. We've gone over just enough information to help you. So what I want you to do is I want you to take a second attempt at writing the baseball program that I showed you earlier. So you're going to rewrite badbaseball.c. And here's what I want you to do. I want you to use 2 arrays for the scores of the teams. Instead of having 9 individual variables, I can just have 1 array with 9 elements. So use arrays instead of using 9 variables. Second, use a for loop so we don't have to actually write code for every single inning. We can just write one piece of code for a inning and loop through it 9 times. And lastly, update the print team function. I'm going to show you how to do that right now because it requires that I give you a little more information about how do arrays get passed into functions. So let me show that to you, and that'll be the last piece of information you need to get started on the challenge. So arrays and functions. Take a look at this function I've created called print ages. Okay, I'm going to have 2 parameters. The first is a count of how many ages I am providing the function, and the second is an array. Now the way that you say to a function that you're going to be passing in an array is you just say a type, a name, and then the brackets. No need to place a number. This function doesn't care how big your array is. It doesn't need to know how big your array is in order for the function to be defined. So you just say, I'm going to give you an array. Doesn't matter what size. In fact, that's what I'm going to use this variable for. I'm going to use count. Maybe it would be better to have called this size. I'm going to use this variable to explain to the function how big the array is. So how do I implement a simple print function for an array? Well, I'm going to use a for loop. I set I to 0. I'm going to iterate through I until it is, as long as it is less than the count. So it needs to be less than whatever number I give here. And that's going to loop me all the way from 0 to count minus 1. And then for each loop, I'm going to print the integer that is stored in the ith location whatever iteration of the loop that I'm on, I'm going to use the I variable to access the array at that particular index. So when I first execute the array, I is 0. So I'm going to get ages 0. On the next iteration, it's 1. So I'm going to get ages 1. On the third iteration, on the fourth iteration, I will be 3. I will access ages.3. Then I will increment I to get 4. And once I equals 4, it's going to fail this count. I'm assuming here the array is size 4. So let's take a look at a main function that I would write to call print ages. I'm going to define an ages array with 4 elements, 2, 4, 7, and 8. Then to call print ages, I simply say print ages. The 4 tells the function my array has 4 elements, because the function has no way to know how many elements are in your array. You need to tell it. Okay? Then, in order to pass in the array, I simply use the name of the array. When I place an array name in a function list, the compiler understands that I'm passing that array into the function. Now this function will have access to my array. We'll learn a little more about this in our next video, how exactly this is working, how is it happening that this function can get access to this array. We'll talk about that more in the next video, but for now, this is enough information for you to be able to write the programming challenge. So what I encourage you to do before you write the challenge is take a look at Program 10 Arrays, where I've gone through a number of examples of defining arrays, changing the values in arrays, and looping through arrays. So get familiar with some of the basics of how arrays work. Then you can use the bad baseball program to steal some of the code that I've written. For example, the get random score, you might like to reuse that. You're going to have a print team function. I've asked you to rewrite it, but maybe you can reuse some of this printf work that I've done here to help you. So take the bad baseball program, rewrite it using arrays, and we'll see you in the next video where I'll explain how you could have solved this programming challenge and make sure you're getting a hang of arrays. As always, thanks for joining us, and we'll see you in the next video.